We explain how graphene could speed up the development of the Internet of Things. This is Josie. Josie lives in the near future and loves to use the Internet of Things in her everyday life. For example, her clothes use the flexibility and excellent sensing capabilities of graphene. Now she can conveniently integrate a daily health checkup directly into getting dressed. Her flexible roll-down bathroom mirror brings her up to speed before she even started her day. Graphene's flexibility and ultra-thin body enables the realization of transparent displays in nearly any shape and size. Josie's daughter Carolina is passionate about swimming and dreams of one day making the Olympic team. With graphene sensors integrated into her swimsuit, she can receive a lot of information, helping her to train more efficiently. While Carolina is swimming, Josie goes to the supermarket. She will get relevant information on products thanks to smart tags made flexible by graphene, as well as graphene optical sensors that can see things that the human eye cannot see. By scanning a product, Josie can see if it's fresh or if it contains any additives or allergenics that she wants to avoid. At home, Josie's son Adam opens the fridge to have a snack. By a graphene tag integrated in the label of the yogurt, he can check if it's still edible even though it passed the expiration date. That way, the family avoids wasting food without risking their health. Adam is into gaming with his friends over the internet. Graphene can speed up the transmission of information as it transforms optical signals to electricity and vice versa with record speed. Even wireless communication is improved, and Adam could even join out of an airplane. Carolina's swimming coach also enjoys the benefits of this high-speed transmission. He receives signals from the swimsuit while monitoring Carolina's swimming technique from the poolside. As Josie is driving home, it's become dark and foggy. In these conditions, when her own senses can betray her, graphene is used as a reliable optical sensor that will bring her home safely. Since graphene is thin, flexible, transparent, and cheap to mass-produce, Josie and her family can apply unique qualities to the things they depend on. This way, they can personalize their things and are able to focus on what's really important. We explain how graphene could change the way we drive. This is Maria. Maria and her research team are part of the Graphene flagship. They explore how the superior properties of graphene and related materials could be incorporated into and add functionalities to many parts of a future car. Maria and other researchers foresee that in the future, cars will drive by themselves. This is great news, especially for Maria's husband Phil, who will have time to finish work on the way home. Thanks to graphene's excellent sensing capabilities, his car will be able to find its way and accurately estimate distance to other cars and obstacles, also in difficult conditions such as fog or at night. If he prefers to drive himself, sensors in Phil's car could check his vitals through the steering wheel to make sure he's not falling asleep or suffering heart problems while driving. In order to lower the usage of non-renewable fossil fuels, Maria's team is also working to develop alternative engine technologies like electrical cars. This demands new design and material requirements like lighter composites, longer-lasting batteries, and improved corrosion capabilities. By combining graphene-enhanced batteries with graphene-enhanced supercapacitors, the electrical car will be able to accelerate faster than those with the regular batteries, so Phil will be off faster once the traffic light turns green. Maria could also apply a protective graphene coating to the chassis, enhancing the ability to prevent chips, dents, and corrosion. Graphene-enhanced composites have 10 to 30% improved material properties, making it possible, for example, to produce faster, lighter, and more resistant tires. A graphene coating inside the wheel could also reduce temperature buildup. Graphene is thermally conductive, heating things when they need it and cooling them off when they get too hot. Phil especially appreciates this, as his car will stay cool when parked even on hot summer days. In winter, he would save time too. A transparent layer of graphene will keep his vision clear, and Phil won't need to scrape his windshield anymore. Technological development will change the way we transport ourselves, and graphene has an important part to play in order to make our driving both safer and more comfortable. We explain how graphene could be used in biomedical applications to improve people's lives. This is Stan. Stan is blind, but he hopes to be able to take part in a clinical study using graphene devices that could help his eyesight go from pitch black to perceiving shades and shapes. How is this possible? Graphene has the ability to electrically stimulate the nervous system of the brain. There, it could record the electrical activity of the nerves and inject charge into the optical nerve and produce an image from an external camera. But Stan is not the only patient that could benefit from graphene's attributes. His best friend Anna has epilepsy. Anna is following recent studies that show how graphene could be placed into a delicate sensor, able to detect the specific areas in the brain that are responsible for the seizures. That way, clinicians could understand where exactly in the brain the episode is happening and how it can be predicted or even cured. During her research, Anna met Sophia, a scientist. She explained one of the key advantages of graphene devices. Their multifunctionality can both record and stimulate the electrical activity of the brain, as well as locally release therapeutic agents on demand that could offer multiple treatment options. That's also how the doctors hope to be able to help Sophia with the effects of Parkinson's disease. This new generation of thin and flexible graphene-based devices could minimize shaking, tremor, and other motor symptoms. While the graphene flagship scientists focus mainly on blindness, epilepsy, and Parkinson's disease, research in the use of graphene and 2D materials in medicine is expanding globally. Some other biomedical applications currently under development include cancer treatment, tissue engineering, and drug delivery. In addition, graphene's thinness, flexibility, and excellent sensing capabilities makes it suitable for use in wearables, providing Stan, Anna, and Sophia basic health checks that they can monitor themselves and use to inform their doctors. Although research on graphene for medicine is still at its early stages, tests show promising results that could offer medical professionals new, multifunctional, and more precise capabilities and help improve the quality of life for millions of patients worldwide.